For the function f of x is x squared plus 2x, find the gradient function using first principles. Hence state the gradient at x equals 2. So we know it's a quadratic. And if we say the point P here has x-coordinate x, then we can see the y-coordinate will be x squared plus 2x. If we take a point Q here with x-coordinate x plus h, so what we're saying is that the distance from here to here is h, then x plus h squared plus twice x plus h must be the y-coordinate. Now this distance is the difference in the y-coordinates, so that would be x plus h all squared plus twice x plus h, take away x squared plus 2x. So delta y over delta x is going to be, so what we're doing is working out the gradient of the chord, and of course then we're going to shrink h down to 0 to get an estimate of the gradient of the tangent. So that's going to be x plus h all squared plus twice x plus h, take away x squared plus 2x all over h. So that's going to give us x squared plus 2xh plus h squared plus 2x plus 2h, take away x squared plus 2x all over h. So the x squareds will go and the 2x's will go. So we'll have 2xh plus h squared plus 2h over h, which is 2xh over h plus h squared over h plus 2h over h, which is 2x plus h squared plus 2. Now dy dx, the gradient function, is the limit as h tends to 0 of delta y over delta x. So tending h to 0 is not going to affect 2x, it's not going to affect 2, but this one here will just go to 0. It wouldn't be h squared, of course, it would just be h. I forgot to cancel that down. So h squared over h is just h, but nevertheless it goes to 0. And so what are we left with? We're left with 2x plus 2 as the gradient function. So at x equals 2, dy dx evaluated at x equals 2 gives us 2 lots of 2, add 2, so that's 4 and 2, which is 6.